So it is day 21 in Algebra 1, and it is Monday, April 28th. Just going to write my date on my paper. Monday, April 28th. Okay, and for your do now, I just put some expressions up on the page and wanted to see how well we remembered things from last week. So let's start with number 1. I have 2x, and then beside it in parentheses, 4x plus 3. What operation will we need to use to simplify this? Distribution, multiplication, absolutely. So, what am I multiplying first?
2x times 4x.
Good. 2x times 4x, which gives us what? 8x squared. 2 times 4 is 8. X times x is x squared. Okay, so I've done that. What am I multiplying next? Yeah, plus 2x times 3, 6x. Perfect. Can I go any further? I can. What can I do? I thought we were done. 8x squared plus 6x, I can put those together?
They're not like
Oh. The exponent, this is where it gets really tricky. So remember, like terms, I'm going to write this definition one more time. Like terms, they need to have the same variable and the same exponent. If one has an exponent and the other one doesn't, they're not like terms. Same variable and exponent or power. Right. So now that we have our reminder of what like terms are, 8x squared plus 6x. Why are these not like terms? There's no exponent on 6x. So this is as far as we can go. That's it. We can't go any further. Okay. Any other questions about number 1? Just a good little reminder there. Okay, let's go ahead and look at number 2. Now I have 5x squared over x. What operation will we use to simplify this? Division and essentially subtraction, yes. So 5x squared divided by x. It's just going to be 5x. How did you get that? Right. So we're always looking at the whole numbers first. 5 divided by, well, there's not a number there. 5 divided by 1, basically, which is 5. And then x to the second power divided by x to the invisible 1. 2 minus 1 is 1. So I guess I could do 5x to the first power, but in the real world, you're not going to have a 1 beside it. It'll just be 5x. Right. Everybody got number 2? Awesome. Let's look at number 3. What operation will I use here? Yes, multiplication and distribution. So let's start here. 5x to the third power times negative 4x. Good. Negative 20x. 3 and 1 is 4. Perfect. Negative 20x to the fourth power. What do I do next? Okay, so positive 5 times negative 2 will give me a negative 10. Good. Negative 10x cubed, or to the third power. Okay. Make this one addition. The first one. Yes. Same exponent right here, but we have x to the fourth power and then x to the third power. So we can't go any further here. We need to keep them separate, right? Because the only time that we can combine them as like terms is if the exponent has the same number. So 3 and 4 are different. Yes, so they stay separate. We remember that, guys? Okay, so they have to have the same exponent. They do both have exponents, but they're not the same. These are different ones. So let's see. Is anybody confused about how I got any of the numbers that I just wrote down? So if these numbers were the same, bless you, if these were the same numbers, then we could put them together. But because 4 is not the same as 3, we cannot put them together. They're not like terms, right? So this will actually be our answer. We can't go any further with it. We can do nothing. No, because we started with x to the third power times x to the first to give us a 4 here. And here we have x to the third power times, oh, well, there's not an x on this one. So now we have x to the third power. We can only put them together if the numbers are the same. But since these are different, we can go no further. This is all we can do. Okay. Any other questions? Any comments, concerns? Learning as we go. All right. All right. Let's look at number 4. What operation will we use here? Division and basically subtraction. So first, what do we do?
48 divided by 4.
Perfect. 48 divided by 4 is 12. X to the 8th power. How did you get x to the 8th power? 10 minus 2 is 8. Good, 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 good. So another way we can do this, if we ever forget to subtract, is I know x to the 10th power means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over x to the second power, x squared, 1, 2. If I cancel out 1, 2, 1, 2, there are 8 x's left. 1, 2, 3, 4, 5, 6, 7, 8. That's where we got to the 8th power. Just dividing, just canceling x's, canceling numbers. Okay, so 12x to the 8th power is our answer. What number did you get for your power? Just 12x. Just forgot to do them. That's okay. Whenever we're dividing, just remember all we do is subtract the numbers. When we're multiplying, we add the exponents.
Oh, okay.
Yes.
I did.
Okay, good. All right. Anything else for number 4? Let's look at the last one. Number 5, negative 2x squared. And by now we should know this is multiplication or distribution. We have negative 2x squared times 6x minus 5. So let's start here. Negative 2 times 6 is negative 12. Good. And then x squared and x1 gives me x to the third power. Now I have negative 2x squared times negative 5. Good. Plus 10 squared. Good. And this x squared we have because there was no x on 5. We just carried it over from the negative 2x squared. And that is as far as we can go. These are not like terms because 3 and 2 are not the same. Okay. All right, that was our do now. So we're going to move forward and learn about something new today. And all this practice we've been doing with like terms and distribution and the division is what is going to lead us up to what we're learning today. So my hope is that this has helped to kind of bring all those rules back into our brains. And I'm going to grab my notebook and we're going to take some notes. So, put that here. And we are going to get started. So, this is Algebra 1, Unit 3. And this is our Day 21 notes. And this is page 1. Okay. So, today we are going to talk about something called a binomial.
Oh, that's what
Oh, yeah. Binomial. Does anybody know what a binomial is? Any idea? Let's break the word down into 2 smaller sections. We have the first part, bi. The second part, nomial. Does anybody have an idea of what this, it's called a prefix, the beginning of a word? Is it? 2, yes. Bi means 2. This is what bi means.
binomial makes me think numbers.
Yes, you got it. Yes. Bi means 2. Nomial means numbers or terms. So, 2 numbers or terms. That's what a binomial is. A binomial is 2 numbers or 2 terms. So, for example, in our do now, number 1, number 3, and number 5, those 2 terms that were in parentheses are binomials. So, for example, let me give you a few examples. Example. A binomial could be, now these also can't be like terms. 2 numbers or terms that can't be combined. So this could be like 6x plus 3. That's a binomial. Another example could be like 12x to the 3rd power minus 4x. That's a binomial. There's 2 terms. The term is including the number and the variable and the exponent. 6x is a term. 12x to the 3rd power, that is a term. Okay, so both of these have 2 terms. So we have been working mostly with, whenever we're multiplying, we've been multiplying a single term by 2 terms, by a binomial, using distribution. But now we're going to move up to the next level. and we're going to try to multiply a binomial by another binomial. Yeah, it's possible. I know. So here's how we do that. We have some special methods. First, I'm going to write right here, multiplying binomials. And we'll start with some pretty simple ones. Let's start with x plus 3 times x plus 2. X plus 3 times x plus 2. There are two methods that we're going to learn about. The first method I'm going to teach you today is called the FOIL method. Has anybody ever heard of the FOIL method? This might be the first time you've ever heard it. So here's what we're going to do. I'm going to write over to the side FOIL, FOIL, and I'll show you what that means. For these two binomials, to multiply them, come on in. Okay, so here's what FOIL means. It is an acronym, so it stands for 4 different words. F stands for first. O stands for outer. I stands for, I'm running out of room, inner. And L stands for last. First, outer, inner, last. So all this is giving us is kind of a guideline for which terms to multiply together first. So the first terms, we're talking about the first term on each binomial. Here's the first term, x, of this one. The first term of the next binomial is also x. So first, in FOIL, we're going to multiply x times x. That's our first terms. So for f, I'm doing x times x. What is x times x? X squared. Good. Okay, so we've done the first terms. Next, we're going to move to the outer terms. And that is just referring to the terms on the outside, the x and the 2. These are the outer terms. It's just like distribution though. See that? So now I'm doing O, outer, x times 2. Now what is x times 2 or 2 times x? 2x. Good. 2x. Okay. So now we've done the first terms, we've done the outer terms. Now we need to do the inner terms, inner. Those are going to be the 2 terms in the middle, 3 and x. So now I'm going to take an arrow from my 3 to my x. That's my inner terms. And what is 3 times x? 3x. Good. 3x. Okay, and last but not least, my last terms, L in FOIL. My last terms are going to be the last numbers or items at the end of both binomials. So I've done 3 times x. Now I need 3 times 2. So 3 times 2. And 3 times 2 is 6. Good. Okay. So all we're really doing here is we're using distribution, but we're taking turns on which term we're looking at. First, I'm taking x and using distribution, x times x plus x times 2. And then once I've distributed x to everything, I just go to the next term, which is 3. And I use distribution, 3 times x and 3 times 2. It's just like repeated distribution. That's really all it is. So if you ever forget, there is the fancy acronym, first, outer, inner, last. I think it helps sometimes to have this method. So what did we just find? I don't know. Let's like put some actual meaning to this. We have all of our terms here now. I know I have x squared, 2x, 3x, 6. What we need to do now is take all these terms and write them together. And when we do that, we just put plus signs in between them unless they're negative, but these are all positive. So I'm just going to pull these out. I have x squared plus 2x plus 3x plus 6. Okay. X squared plus 2x plus 3x plus 6. And there's one more thing I can do. Yes, that's the last step. Notice that we have 2 terms that both have x. So we need to combine these. How do we combine these? You just add them. So 2x plus 3x, yes, 5x. So we just bring everything else down. X squared plus 5x plus 6. And that is our answer. So we went from 2 binomials, we multiplied them, and now we have a trinomial. Very fancy. You don't need to know that, but just a fancy word. Okay, so that's an example of how we multiply 2 different items that have 2 different terms. It's just repeated distribution, just multiplying, and then we end up with this. So let's do another one together using that method. And I don't want to move this up yet if anyone is still writing. Let me just pause this for a moment. So moving up, let's do another one together. Let's do, how about we add a number on our x? Let's do 2x plus 5 times 3x plus 3. 2x plus 5 times 3x plus 3. And I want to use the FOIL method. FOIL. So if I'm using this method, how will I begin this problem? What will I multiply first? 2x times 3x. Good. The first term from both binomials. 2x times 3x. That comes first. Get a different pen. And I'm just going to write below here 2x times 3x. What is 2x times 3x? Good. 6x squared. Okay. What do I do next? My outer terms, which are what? 2x times 3. Good. I don't know why I wrote that not on the line. That's going to bother me. 2x times 3. Okay, and what is 2x times 3? 6x. Good. And what do I do next? My inner terms. Which terms are my inner terms? Perfect. 5 and 3x. So 5 times 3x, which is perfect 15x. And last but not least, perfect, the last terms of each one, 5 times 3, 15. Perfect. Okay, so we have done each of the 4 steps in the FOIL method. And now we have 4 terms, 6x squared, 6x, 15x, 15. Let's start by writing them all out in a line with plus signs in between them. So we will have 6x squared plus 6x plus 15x plus 15. Okay. So I have them all written out. What can I do next? We can combine our like terms. Which are the like terms here? 6x, 15x. Both of them have the same variable, x. So 6x plus 15x is 21x. Now, is it x or x squared? Just x. Good, good. So 15, 6, 21x. And then we just bring the rest down. 6x squared plus 21x plus 15. And that's our answer. Okay. Yes. Okay, so that's a great question. Whenever we are combining like terms, we're only adding the numbers. We're basically saying, in this problem, I have 6 x's and I have 15 x's. When I add them together, the x's are still x's, we just have 21 of them now. If I was multiplying, that's whenever the exponents, we would add them together. So like if it was 6x times 15x, then I would have x squared. Super easy to mix that up. Just will take more and more practice. And what's great about these problems is they all end up exactly the same. So once you've done a bunch of them, it really starts to make sense. You're always going to go from 4 terms to 3 terms. There's always going to be something to combine in the middle, almost always, unless there's like a 0 in there or something. But in general, it's all going to go like this. So before I have you guys try 1 or 2 on your own, I want to open the floor to questions. What kind of questions do we have or questions that you can come up with that you think might be helpful to someone learning this for the first time? What's confusing? And I've only shown you two. A question could also be, can you please go through another one before we do it? Yes, absolutely. Okay, perfect. So I'm going to go ahead and start a new page. I'll leave this up here while I title this, and then we'll do another one together. Algebra 1, because this is brand new. I'm just now showing it to you. Okay. Bless you. All right, so let's look at another example. How about we try, let's do 4x. We're going to keep them all positive numbers for now. We're not going to throw any negatives in there yet. Let's do 4x plus 1 times 2x plus 3. Do 1 minus? Okay, we'll do a minus next. We're going to keep it plus for now. Minus will come next. Okay, so we're going to use the FOIL method, meaning, here, let me see if I can give like a x plus a, x plus b. Here's the first. Here's the outer. Here's the inner. I don't know if this visual is helpful or way more confusing. Here's the last. That's where we're getting those FOIL from. Okay. So what do we multiply first? My first number is 4x and 2x. Okay, 4x and 2x. What do I get? 8x squared. We're multiplying, so the exponents will change. We don't add the x's when we're just combining like terms. So whenever we're adding, we have like 6 x's and we have 15 x's. I add them together. Now I have 21 x's. Whenever I multiply 4 x's times 2 x's, since we're multiplying, the exponent does change. When we're combining like terms, they don't. When we're multiplying, they do. Okay. Yeah. I'll come up with something to make that easier to remember, because that's something other classes struggle with too.
So would it be addition and subtraction, exponents don't change?
Yes.
Division, they can't.
Yes. 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 When we multiply, the exponents add. When we're just adding, you're not doing anything to the exponents. Okay, so I did my first terms. 4x times 2x is 8x squared. What do I do next? My outer terms, so 4x times 3. Good. 4x times 3. And that will give me what? 12x. Perfect. Okay. Next, we'll do the inner terms, which are, which ones? 1 and 2x. 1 times 2x is 2x. Good. And last but not least, 1 and 3. Perfect. 1 times 3 is 3. Good. Good, good, good. Okay. And it might not be a bad idea to just go ahead and look at this stack that we have here before writing it all out and then combining, especially when they're all stacked on top of each other. Sometimes it's easier to recognize the like terms. So before I write it all out, can I combine anything? 12x and 2x. Am I going to change my exponents? No, because we're just adding. What is 12x plus 2x? 14x. Good. So now when I write everything out all together, I have 8x squared plus 14x plus 3. And that is my answer. 8x squared plus 14x plus 3. Okay.
So you just basically simplified it?
Yeah. Basically. That's all we did. Okay. Can you try one by yourself? Okay. I'm going to give you one to try on your own. Don't worry about getting to that worksheet yet. I want to just see how we're doing with this. So try this on your own. And then we're going to stick some negatives in there. Here's another one. Okay. Try these two on your own. And I am going to set a little timer for you. And then we'll see how we did. I might come around and check on you guys too. Okay, so let's look at number 1. What do we do first? 5x times 6x, which is good, 30x squared. Okay, so what I'm doing here is I'm not writing out all of the individual multiplication problems to save a little space, save a little time. If anybody needs me to write that out, just let me know if that, helps a little. So we did 5x times 6x, 30x squared. What do I do next?
5x times 4.
Good, 5x times 4, which is 20x. Perfect. Now what? 1 times 6x, which is 6x. And last but not least, 1 times 4, which is 4. Okay, so this time I just separated it into the 2 distribution problems with colors. Okay, same exact thing we did before, I just didn't write out all the separate multiplication problems. So, what needs to be combined? 20x and 6x. They both have x's. So, we're going to add those together, giving us 26x. So, 30x squared plus 26x plus 4. And that would be our answer. How'd we do?
Great.
Good. Good, good. Okay.
Yeah. I think I did.
What did you get on yours?
I got 30
Mm-hmm.
eggs. The second plus
Perfect.
20
Mm-hmm.
plus 6 eggs
Perfect.
plus 4 equals 16.
Oh, you had it until after the 4. I don't know where that came from. Well, as long as you got that first part, you're doing it. You're doing the process. You're getting the correct numbers. That is good. Once you have those 4 terms, the only thing you need to do next is combine the 2 middle ones, 20x and 6x, which turn into 26x. I wonder where the equal came from. I don't know. Oh, okay. Any questions, comments, concerns?
I noticed my mistake and I fixed it, but I accidentally tried to add a 1 on the
Yeah. It's so easy to mix those up. So easy to.
So
Okay.
is it always the middle ones that you gotta combine?
As long as you're doing it in this order, yes.
Okay.
Don't always just say it's always the middle ones. It usually will be. It's always the ones that have the same variable. Yes. Yes. Perfect. Okay. Let's look at number 2. What should I do first? 4x times 2x, which gives me 8x squared. Then what? 4x times 2, 8x. Okay. And what's next? 5 times 2x, which gives me perfect 10x. And last but not least, 5 times 2 is 10. Okay, so 8x squared plus 8x plus 10x plus 10. What do I combine? 8x and 10x. 8 plus 10 is 18x. Okay, then I just bring everything down. 8x squared plus 18x plus 10, and that's my answer. How do we do on that one? Great. I see your face. What are you laughing at?
Myself because I just need to slow down. I can hear Brian in my ears. Slow down. Slow down. Just slow down.
Right.
Because I done wrote the wrong numbers.
Oh, I gotcha.
Yeah.
Did you write, was it the original problem written wrong or just one of your steps?
Because what I do is I rewrite and I move stuff down
Yes.
close to where it's for and I got it.
You got it. You got it. Okay, let's look at number 3, the last one. Okay, 2x minus 4 times 3x plus 5. So we'll start at the beginning like we've been doing. 2x times 3x. What is 2x times 3x? Perfect. 6x squared. And then what? 2x times the plus 5, positive 5. Yes. And what does that give me? 10x. Good. Okay, now I snuck a negative in here. We have 2x minus 4. So when we're multiplying this second term here, I'm not just doing 4 times 3x and 4 times 5. We're going to consider this a negative 4. Okay? That way we get the right sign in our answer. So negative 4 times 3x, what is that? Good. Negative 12x. Okay. And negative 4 times 5, negative 20. So now when we combine our like terms, we need to be careful because we have a subtraction problem. We're not adding them, we're subtracting. I have 10x minus 12x. negative 2x. Good. So negative 2x is my new middle term. I will bring everything else down. 6x squared minus 2x minus 20. How did we do on that one? The negatives are tricky. It really messes us up sometimes. Okay. Do we have any questions? Anything at all? For the people that didn't give that confident, oh yeah, I got number 3. Are there any things you noticed that were mistakes in your work that now you understand?
I need more practice because I was writing as she was explaining, so I did not catch it.
It's all right, girl. I got that worksheet that I gave you guys, and hopefully that will give us some good practice today. And I think sometimes more questions arise just as we do more practice. But I think this is a great start. So here is what we are going to do. There's this FOIL method to doing it. And what I would like you guys to do now is look at this worksheet that I passed out, okay? There are 20 different problems that I came up with for you. Now, there is more than one way to do these. I've only shown you the FOIL method, so I'm thinking I might show you the other method before I have you get started on these, just so you can kind of decide which one you like using better, in case you like the other way better. So let's show that other method on this worksheet. That's what I'm going to do. Let's see. So we just did the FOIL method. Moving on with my notes. And now I'm going to show you one more method. So let's grab this worksheet, pull it out. And on number 1, we're going to use this.
But still consider the full.
Yes, this is a different method, but it will give you the same answer. They both work no matter what. It just, whatever you prefer. So the next method is called the box method. I'm going to show you that one here. So to do the box method, what we need to do first is give ourselves enough room. Underneath the first binomial, right here, we have 3x plus 2. I am going to draw a box like this. And I'm going to draw a line straight down the middle. And then I'm going to draw a line across. It's going to look like a window. Okay. So here is my box. You might love this method. You might hate it. You don't have to use it. So we've got our window, and here is how this method works. Above my box on top, I have 3x, and then I have plus 2. I have x plus 3 over here, so I'm going to move that over to the side. I'm going to write x right here. I'm going to write my plus 3 right here. I'm just going to cross that off since I rewrote it. So now we have everything kind of stacked up, and we're going to use this the same way that we would use a multiplication table, which I believe I have one somewhere. This, ladies. So this is a multiplication chart, and the way that it works is anything that lines up with the numbers on the outside is a product. It's the multiplication of those two items. So for example, 1 times 1 is 1. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Do you see how that all lines up? Okay, we're going to do the same thing with this box. So in my first box, I'm multiplying x times 3x. What is 3x times x? 3x to the second power. 2 x's, 3x squared. Okay, we got that. 3x times x, 3x squared. In the second box, I'm multiplying x and 2. What is 2 times x, or x times 2? 2x. Good. So now I have 2x. So I have my first two boxes filled out. Now I go below and I'm multiplying 3 times 3x. What is 3 times 3x? 9x. Good. 9x. And last but not least, I'm multiplying 3 times 2. 6. Okay. Now you have all your 4 terms. And to combine your like terms, what's kind of fun about the box method is your like terms are always going to be in this diagonal, 9x and 2x. And that is 11x. So 9 plus 2 is 11x. So now we just bring everything out and write it in order again. We have 3x squared plus 11x plus 6. So that's another method. You can do it that way too. Just depends on if, like, I know some students who are more visual and they really like the box method because it lays it out in a way that makes more sense to them. And then I have others that love the FOIL method. I have others that don't really use either one. They can just do it in their head, which is pretty impressive. But anywho, do you want to see one more example of the box method? Run through it one more time, or did that make a lot of sense? You like the FOIL? That's what I liked whenever I was in high school. I liked that too. Okay, well, that all being said, it is 2:05. If you would like to take a break, you're welcome to. However, I am gonna set a timer, and I would like for you guys to do as many of these problems as you can. Just get some good practice in. And I am going to have this be your exit ticket today. Okay? So, even if you don't get them right, all of them, your exit ticket is to do all of these, to get all the practice. Okay? We will do an accuracy grade on this stuff tomorrow. Today is more about getting it in our brains. So, I'm going to pause our recording. You guys can work on these, or you can take a break, or if you're done, then I guess you're free. So I'm going to pause that and let you guys choose what to do with the rest of the time. So quickly, everybody just take a peek at number 3. No matter which method you decide to do for number 3, you may have some problems like this, and here's something that gives it away. Notice that I have 2x plus 3 and 2x minus 3. All terms are the same, but one has a plus and one has a minus. When you have the same numbers, but one has a plus and one has a minus, you're going to end up getting numbers that cancel out. So if I were to solve this, 2x times 2x That gives me my 4x squared. 2x times negative 3 gives me negative 6x. 3 times 2x is plus 6x. 3 times negative 3 is minus 9. Okay, so now we're here, and let's see what's going on. I have 4x squared minus 6x plus 6x minus 9. When I'm combining my like terms, minus 6x and plus 6x, what happens to these terms? They're canceling out. 6x and minus 6x. When I put these together, I get 0x. We don't write 0x. We don't even write 0. They cancel out. Yes. Cancels. So our answer would be 4x squared minus 9. So sometimes that will happen. If your middle terms have the same number with just a different sign, they will cancel out. This is a special case. So you may see this. Just wanted to show everybody what we would do in that scenario. So thank you guys for pointing that out. And pause again.